So you have got this in the Google Drive. You have this ground motion parameter pptx file is there, right? Everybody see that file? Everybody can see this file? Okay, so in the ground motion parameters, as I discussed in the class last time, that we have few parameters. One is the amplitude parameters, one is the frequency content parameters, one is the duration, and other is the other ground parameters. So that we will be talking about. Now, the amplitude parameters means these are the peak ground acceleration, peak ground velocity, peak ground displacement, and other amplitudes, which is the effective acceleration, sustained maximum acceleration, sustained maximum velocity, and effective design acceleration. So these are all basically part of the amplitude parameters, right? So amplitude parameters are, these are the types, right? Then we have a frequency content parameters, which has the ground motion spectra, the spectral parameters, and this is the ground motion spectra means it's basically the Fourier spectra, power spectra, response spectra, and effective design accelerations. And then the spectral parameters is the predominant period, bandwidth, central frequency, shape factor, and Kenai Tazemi parameters, which I have not touched upon, but we can learn about it. And then there is a duration parameters, which is the bracketed duration and effective durations, right? And then lastly, the other ground parameters, which is the RMS acceleration, areas intensity, cumulative absolute velocity, velocity spectrum intensity, acceleration spectrum intensity, effective peak acceleration, and effective peak velocity. So these are the parameters which we can calculate from the recorded ground motions, right? So all the parameters you need to compute, and you need to say, suppose one of the time history, just I had given it last time, say K220 or K209 time history. You have a 3 component, and the first is the time. So from there you can calculate these parameters. Now the how to calculate these parameters, or what is the formula of calculating that, we already discussed it in this I think that was the lecture 3. Yeah, so effective ground motion parameters, estimation of ground motion parameters. We have discussed all the, let me see. Say, how to calculate PGA, how to calculate peak vertical acceleration, peak ground velocity, PGV, PGD, so effective acceleration. So this we have already discussed here. So you can take each one, the significant duration, this RMS acceleration, total intensity, how to calculate that, average intensity, cumulative. Oh, let me see. This is a Google Doc. I do not know what to do this one. এটা হবে এইটুকু দেখে so the cumulative absolute values, the areas intensity. So these values are already given to you. So you can, let me see how many of you can translate these things into the code. Okay, so start from the first, the peak ground accelerations. So you have the acceleration, 3-component acceleration. For each component, you first calculate the peak ground accelerations. So you read the one component or one station data. That means the first column is the time, second column is the accelerations. This is the north-south acceleration, then there is a east-west acceleration and the vertical acceleration. So for each component, you first calculate the peak ground accelerations. So peak ground acceleration is value. So this is your peak ground accelerations, right? দেখো হচ্ছে Is it okay? So let me see what will be the peak ground acceleration values for each one. So everybody is using MATLAB or somebody is the Python? Okay. Let me see. Let me see. But I will come to you. We'll see. Calculate the peak ground acceleration from the recorded data. I have given you the record yesterday. So take one of the component and let's see the K220 and calculate for the 3 columns the maximum the highest value. No, don't. Are you doing it from the previous one?
Yes, sir.
No. You write a different code. Don't do all the codes in the same. Just write another script file. Open another new one because there are a lot of things you have to do. North, south, east, west, and vertical. Okay.
3 to 4th column is north, south, east, west, and vertical value.
Fourth column is what?
Vertical, sir.
Second column. First column is?
First time, sir. Time series.
No. That you need not to calculate. That's
actually 45.
We have calculated all the columns.
Huh?
We have calculated all the columns.
Maximum.
No.
Okay.
You have to find the absolute values of maximum. Because it could be the minus might be the minimum will be the maximum one, right? So because on the downside there will be the maximum. So you have to calculate absolute of that maximum.
Yes, sir.
Okay, so not always the positive. We need to have a writing board so that we can. I will be bringing there. But then this will be getting off. Let me see. No, it will be okay. No. Oh, okay, that's fine. I can, yeah. So, how to change the color? Maybe the red will be better. So if you see the accelerometer or this one, it could be the minimum or this one might be the maximum one, right? So might be this one. So you have to take the absolute values of these data sets. So absolute of the maximum of the absolute numbers. So not that always the positive will be the maximum. It's not the case, right? So so it becomes now 320. 266.
And then change the value of east west and vertical.
So east west is how much?
East 248. Vertical 3.
Oh, vertical, yeah. And the vertical is?
359.
Okay, and then go ahead with the other. Now you calculate the velocity. So take the do the trapezoidal rule. Give the a values and the dt. You know the dt values.
सर कल जो आपने स्क्रिप्ट दिया था ना उसका have done the as even back as even तो for K209 this one another one was RTZ and NEZ किया था so this one is NEZ another one was this one so right now you are showing
What is this? The radial transverse and the vertical, right? Yes, that's true.
radial transverse so radial transverse vertical so from this to we need to pick that
No, you just take the north, south, east, west and vertical.
okay
Just take the north, south, east, west and vertical and calculate which one is the maximum.
maximum of the absolute value for each of them
Each of them. तो आपके मोहल्ला के माने क्या हाल है? ठीक ठाक चल रहा है?
कुछ एरर आ रहा है कुछ एरर आ रहा है
क्या आ रहा है? What's the error? So K2 time his dot that is not found. Again, you are not in the same folder. You need to have a same folder. I told you yesterday that wherever you are cooking, your oven into that room. Otherwise, you cannot cook the things, right? So can you plot the graph and
the graph
huh? Now plot the graph and show the point where is the minimum or where is the maximum. That will be fine.
101.
Huh? 101. Which one?
Not,
Time?
Not.
No. It's
So maximum count.
but K220. K220.
Yes.
Huh?
Yes.
K220 cannot be that small. K220, the PGA north south is just only the maximum.
Actually, we left the laptop. The other guy was in that we did calculation.
Okay.
And this, he has 119.
1?
119. It's a 2 days, I think.
119 or 199?
119. Another is 101.
No, I have to see it here. Let me bring it here. I cannot see.
Simply we have find to the from the area maximum value we have find.
Hmm.
Yes.
Maximum of W. No, what is W?
W is like absolute we have found.
Where? I did not find out the W here. So this is your. No. Mane, why are you going to this one? Mane, write a new code.
Okay.
Mane, write a new script and read these things and read the data and then find out. Don't mane, mess it up with the RNT things. So mane, write a new code. Write a new equations, right? So how the things are for you? 359, yeah, one vertical one? Yeah.
Yes.
Might be the vertical one is 359. Yes, that's true. And then
I'm trying to.
you try for the horizontal, the two north south and east west. So you integrate it, calculate the velocity, and see how this looks like. So can you calculate the velocity? So it's going on okay?
I'm doing the trapezoidal rule, then I will calculate the velocity.
Are you writing in a MATLAB or
No, in Python. Google
Python?
Colab.
Okay.
Sir, the unit we are thinking that may be wrong here.
What's the wrong?
Per second. It should be in centimeter per second square. No, sorry, centimeter per second. Sir.
Huh.
Yes, sir.
So how much you are getting? 18. Where from 18 comes in? Which one? This one is the.
No, sir, we are confused about the unit that it should be in centimeter per second, sir.
Yeah.
Instead of
So
meter per
multiply
second.
multiply with 100 and get it will be. But how come it becomes because all the values are in centimeter per second square, right?
Yes, sir. 18 meters, sir. 5
So
meters.
so who is transferring it? But how it is being transferred to the meter per second?
Yes, sir. We are also
Can you go
checking-
to the code first? Where you are writing it? Is it a ChatGPT or is it of your things own?
Yes, ChatGPT.
So ChatGPT has done something else, and then you are trying to mess it up with this one. So the ChatGPT has converted it to the meter per second, and now you are asking me that why it is meter per second. So check that thing. So if you do a ChatGPT, then responsibility to the ChatGPT. Don't. Okay, but 190. So I think somewhere or other your multiplication is converted to the meter per second. Are you writing in a MATLAB? Then you can do not the trapezoid. You do a cumulative trapezoid, so that because you are doing it one by one all the calculations, right? So it's a Okay. Okay. So if you are trying to convert it or integrate it acceleration to velocity, those who are using the MATLAB, it is a cumulative, it's a cumulative trapezoid. How to erase it? This one is eraser, right? So it's a cumulative trapezoid. You can see, then give the acceleration value and the time values. Then that will be the velocity. Then the displacement will be the cum trapez, TRAPZ. I think that's the command. Just check it out. If you do the V and then the T. These two will be giving you the velocity and the displacement, and then you can do it with your how to do. How do oh, Yes, you, here it is.
स्लोली ले जाइए 2 घंटा हो गया
भूख लगी है, भूख लगी है। देखिए
For the nodes of it's 18.40, for the east plus it's 21.56, and for the vertical component it's 13.60.
Did it, have you calculated the maximum of the absolute values?
Yes.
Absolute maximum?
Yes, sir. Yes, sir.
Okay, and yeah, looks to be okay. I didn't see the exact number, but might be looks to be okay. And 18, 21 and 13, right? Okay. So you now calculate the PGD. So velocity निकले?
I'm trying, sir.
You're trying, okay. So what about you? When have you find out?
Sir, just doing. The PJ values have come. Just
Mhm.
doing for the velocity.
Okay, good. So what about yours? But anything? So your things are okay coming now? Huh? Have you got it or no? What has happened?
This function is problematic.
Don't write such a big name. Make it a T so the T will be fine. Because this is every time writing time value. It will be very. Just A and T and this will be fine. Okay, that's okay. That part is fine. So, North component, no, you do not need to give a colon. North component means it's a total, all the north data is being taken out. So, you do not need to give it colon. North, that is the beauty of the MATLAB. If you have written one, it is fine. No, first to calculate come trapeze, and then you take the absolute values of that. Okay. Right? The D is also got.
8.024 north south,
Hmm.
and then east west is 11.05.
Hmm. But you have seen that how this displacement is going out. So that is what I was taking. I was telling you that you need to do a proper correction. Otherwise, if you do the come trapeze, it will be looks like that. Okay, so that is the one thing, and we will show you how to do the baseline correction. So if you do the baseline correction, then only it will be straight flat. Otherwise, it will be like this. Okay. So what is your velocity? Displacement values are coming?
Three
3.32, okay.
So after baseline correction, this changes.
Huh?
After baseline correction,
It changes. Yeah. So I told you that you have to do the baseline correction, because otherwise it will not be proper. So how do you do the baseline correction? How do you do the baseline correction?
correction, baseline correction.
No, how you have done it? No, the code. Hmm?
Times.
No, I am saying that this is your displacement north south. This one, but before you have done the baseline correction. Now, where is that baseline correction? This is what I try to understand. That it is your value of error.
Sir, we have also to apply baseline correction on acceleration series also, sir. Or
Yeah, because the
And
acceleration
first-
series has to be corrected.
after that,
After that, if your acceleration series is correct, or the corrected accelerogram, then if you take the cum trapezoid, it will be okay. And then you have to do again correct the base velocity value. Then you do the proper correction. Then it will be the displacement one. So.
Sir, it means that every time, like for the acceleration and again for the velocity.
First those acceleration which has been recorded, it's a raw acceleration. So that acceleration, you first make it a correction. So that means if you get the corrected accelerogram, then you can take the cum trapezoid and do the velocity and displacement, it will be okay.
Sir, one small doubt.
Hmm.
Actually, written for trapezoidal rule, but this is the function, this is the time interval I have taken. Use the formula. This is, I guess, this is for the whole integral. If you want one answer, like from 0 to, suppose this is the acceleration from 0.
Now cumulative trapezoid is each one will be done separately, and then you have to add the things. So that means each one will be going much so that each point you can calculate the velocity values. Because if you have a acceleration here, right? So I need to have a velocity with the corresponding this one. So that means from here to here, if it is a time, then I can first calculate its area and calculate the velocity.
This is my doubt. From 0 to 1, I will calculate a trapezoid. Then, for example, this one, 0 to 1 time interval. Then this will be the displacement for 0 or displacement for 1?
No, this will be the in between.
Okay.
It will be the in between always, as per the rule. But the question is this: we will be doing a cumulative trapezoid, so that each and every point it will be going on calculating. Because it is ultimately integration from 0 to t dt, right? So you have to go on cumulative calculation.
Sir, I got max acceleration in centimeters per second square. Not component in like this. 319.267 for K220. For East it's 248. 359. Is this range correct, sir?
Yeah, I think that will be fine.
Okay.
So then you have to go for the calculating the velocity for all this thing.
And then, so you were also talking about baseline correction.
No, it's okay. You just do the baseline correction. We will be doing it afterwards, not now, because they do not know what they had done.
कर लेंगे
हाँ?
ये दोनों कर लेंगे
ये दोनों कर लेंगे. That's okay. Everybody has to do, so it's not that two people. So
टी इज कमिंग फॉर चाय बोल
Chai.
रहे
So, when in your course, they teach them the Python and MATLAB, right?
No, seismological data analysis. There is another course where I teach Linux, not Python.
Oh,
Linux and some part of MATLAB
I see.
and SOD, SAC.
So there is no specific course for like this software, this programming.
नहीं है क्या मैथमेटिक्स डिपार्टमेंट में नहीं?
But वो जो प्रोग्रामिंग क्लास होता था पहले वो आजकल नहीं होता.
जितने उतने कर दो.
हैं? वो जो प्रोग्रामिंग क्लास पहले होता था वो नहीं होता आजकल.
इंस्टीट्यूट में होते हैं.
हैं?
इंस्टीट्यूट लेवल पर होते हैं.
Institute.
मतलब ओपन इलेक्टिव टाइप या फिर डिपार्टमेंट.
No, those who are from the MSc Tech, they will
They
not
can
take.
attend the classes in mathematics department.
Okay. No, पहले तो हम लोग का जियोफिजिक्स भी था एक कंप्यूटर प्रोग्रामिंग का क्लास.
हाँ.
वो मैंने अमरेश चट्टोपाध्याय पढ़ाते थे. हाँ?
Actually, we will do in masters.
होता है.
Masters में होता है.
हाँ हाँ.
Okay, we used to have like C programming in masters.
Yeah, yeah.
कौन पढ़ाता है? कौन पढ़ाता है?
हम लोग को पेंटिया
पेंटियाला है ना, वो तो दूसरे डिपार्टमेंट के हो गए.
नहीं, हम लोग को एक सेमेस्टर होता है.
एक सेमेस्टर में.
दूसरे डिपार्टमेंट का.
हाँ, दूसरे.
हाँ, दूसरे डिपार्टमेंट का. वो तो कंप्यूटर प्रोग्रामिंग का क्लास होता था. मैंने वी हैव द कंप्यूटर प्रोग्रामिंग.
That is core only C programming.
Only C programming. No.
There is a course on mathematical geophysics, but they do teach or not, I don't know.
I think the last time Sagar said what you do.
They do. But sir, these people are from earthquake science and engineering. They are coming from different colleges.
Yeah. Which one? This one? Oh, this one, yeah. Yeah. But he's a mathematician, so he knows that. तो तुम्हारा क्या कंप्यूटर नहीं है ना? मतलब?
अभी मिस कर गए हैं, मतलब क्लास था ना. एमटेक फर्स्ट ईयर में क्लास था.
Oh, अच्छा. So,
कंटिन्यू नहीं रहा.
but when you have MATLAB in your home,
यस.
okay? In your computer, MATLAB is there, so then it will be fine. So what has happened?
So it's showing some error again and again.
When what's the error?
So cannot import new com traps from site.
Oh no, com trap in your what is called your Python. You have to find out what is the actual name, because the com traps is the name from the MATLAB, so it's not the Python name. So you can make it a Google search and find out that what is the cumulative trapezoid in Python. So find out what is the cumulative trapezoid done in, what is the command of cumulative trapezoid in Python. I think the Python is the integrate cum trap, or what is that? Huh? Integrating?
For PGD.
Huh?
For PGD.
Integrate. No, integrating. No, what's the command? What's the function of in Python? What's the? So suppose in the MATLAB it is the cumulative trapezoid. Then in case of a integrate trapezoidal, or only trapezoidal. Okay. You can try trapezoidal if they said the I.
provide unit for this
Hmm?
unit.
What is that?
We are getting the values, velocity values, but it is in terms of digits, not in unit form, like this.
What you are getting? Let me see.
This is the value.
Yeah, so velocity values, yes. And then you calculate the maximum of it.
But it is not coming in terms of unit, no? As centimeter or meter.
Yes, centimeter. It's a centimeter.
Mm.
It's a centimeter.
But if you want to provide this unit term, where we have to provide?
No, what I don't understand. Let me go back to your code. Hmm. Hmm. So, north component. You do not need to put the bracket unnecessarily.
Okay.
There is no. Yeah. Delete it also. Yes. And then but component CC north component is okay. And then what has happened? So now if you run it, then what is given here? It is given here data, and then you find out the maximum of just the similar way as we have done for the PG, the max of absolute this one.
But there is no function, like you have to make the function for cumulative and then you have to call it.
What they are using? I think.
No function.
They have also made the function and then they have been called.
Okay. So integrate.
Also check the import libraries like
Okay.
trapezoidal, but there is no library of that.
There is no cumulative trapezoidal.
Function.
That. Okay.
This function you have to make and then call it again.
Okay. So, but you get the displacement and velocity values, right?
Yes.
Yeah. So basically, that's by calling this integrate and trapezoidal that you defined it.
Yes.
Okay.
Yes.
Okay. That's fine. No, velocity north. Just write the velocity north. That's it. Don't put the colon, right? Because this is only one number. Okay, but you have to give another one. Yeah, velocity north. Yeah. So now you can see. You can run.
1.57.
10 to the power 4. What is e to the power?
E to the power plus 4.
1571.
1.7.
What is this?
17.
What is maximum velocity of? What is your acceleration comes out? Your east component max velocity north.
This is it, sir?
Max value north. Max value north. Yeah, 319. So let me see. What is the value? $18.39. You can do one thing first. Let me check it out. Oh, you first give the T, then give the A. Not A and T. First give the T, then give the A. Okay, I think that is the correct. I forgot. This has to be this is T comma A, and this is trapeze T comma B. Okay, so just to give the first the T, then the B, and just change the order. No, put the T outside. Yeah, delete the T. Delete T. Yeah, delete T. Yeah. Oops. And T and vertical. And now run it. How much it is giving? Yeah, 18.39. Yes, that's correct. So now you do for the vertical and this. So what are you doing now?
We are checking.
So that has been done, right?
Yes, sir. But what do you use for?
Hmm?
Cumulative trapezoidal rules is different to
Cumulative trapezoid. It's, I don't know. In case of a Python, it might be different way. So
okay, so we just have
Use that trapezoidal rule, not cumulative.
OBSPy. So do you know OBSPy? Well, no, I think it is not being loaded here, right? We'll be doing the OBSPy in the next class, not now. But I first like to see the normal thing is done, then only we can go for the OBSPy things. So it's okay?
31.5586.
See, you are now master. So now you calculate the displacement same way. When you do it, make it mistake, and then learn it, then correct it. Then only you learn. So the main problem is the trapezoid. The trapezoid, if you apply the trapezoidal rule, trapezoid will do the entire frame, right? So that means from one point to the other point, they will calculate the total area, right? But I am not interested in that because I am interested in velocity. So velocity, each and every point I need to have a velocity value. And then I will take the, so that is why it is a cumulative, so that means it's going on calculating from one point to the other point, and then that is a cumulative trapezoid. I don't know what's the Python.
Yes, that is what it is doing. It is only calculating this from here to here using only the area of trapezoid. Area of trapezoid formula. This plus this into the time difference, and
Okay.
this is the.
And then it is giving you the result or not?
It is giving, but something should be corrected. I guess the time difference is. It is giving.
It's giving the value?
Yes, it is giving.
What's the value?
It is little bit.
Yeah.
Should be corrected according to the time 0.005 interval.
You know, in a MATLAB, you can do the two command all together. So you need not to do the velocity and then calculate the maximum value. You can do the trapezoid this, and outside it you calculate maximum absolute. So then you can get the PGD directly in one line. You need not to do the two lines. Okay. So any improvement? No? No improvement? Why? What has happened?
So velocity is not coming out.
Hmm?
Velocity is not coming out.
Velocity is not coming out. So you can go to them. They will be showing you how to define the cumulative values. So they had done it. So you can have some idea from them. Go and check it out with them. They had done some integration values.
ऑफिस आ जाएगी ऑफिस स्टूडेंट को मैं बोल देता हूँ ऑफिस आ जाइए
हम्म?
आप इसके बाद कहाँ जाएंगे ऑफिस वहाँ पे लगा ही
ठीक है,
उसको मैं बोल दूँगा बोले आएगा
ठीक है, आई कैन गो. Hmm.
So this is what I got. K209.
What is this?
Sir, I plotted for maximum acceleration, and from that I applied this one, cumulative trapezoid. So for velocity and for displacement, it's showing me like this.
I don't follow. This is your north, east. Oh, when you are plotting all the three values. Okay, so that's fine. And the maximum value is coming out how much?
Sir, maximum value I have written it.
Okay. Okay, so that's okay.
Yeah.
But your this value is going a little bit crazy. So this value has to come to down. So basically,
The green one.
green one,
That means the Z1.
Z1, yeah, vertical one.
For K, so this is K209. There are other two also.
Okay.
Maybe let us see that one. K210.
A little bit. This is
Green
also
one.
a little bit out. Next.
K220.
It's a bit less, but it is still not zero. It's zero, but not yet zero. But that's okay.
The Z1, no, sir?
Yeah, 01 is zero, but not yet.
Okay, so that is why you are saying some correction.
Some baseline correction is needed. Yeah, yeah,
That means for 209 we have to do the correction.
yeah. Definitely, we have to do.
Okay.
Hmm.
Alright, sir, and right now,
Hmm.
for all three azimuth, distance is azimuth, back azimuth, and distance for three stations are reading this, and I've edited. That's why acceleration right now is not showing, but I can
Yeah.
edit the script and it will only show acceleration.
Okay. But you calculate the velocity at peak values, right?
Yes.
Okay. The Hmm?
Yesterday's code I have saved to GitHub and kept it private.
Mm-hmm.
So today's one also I will save it. So because, for example, if in future I want to just access,
Right, right.
then I can just download it and
Yeah, you can keep it all your program with you, so that's fine. But you finish it today because there are a lot of other parameters we need to do. So quickly.
so
Mm.
for ABD I'm saving differently. And after that, other things will get done.
Yeah. Basically, the other things means the other ground motion parameters we need to calculate, right? So there are a lot of parameters we have to do. So this is your effective design acceleration, all these things we have to calculate. Significant duration, the RMS acceleration, all these things we have to calculate, right? So. you define the PGV and PGT with acceleration and dt is the time difference, right? So first you define it, and then you can calculate velocity will be equals to integrate dot cum trapezoid acceleration dx equals to dt at initial 0. So these are the two commands you can use.
Displacement.
It is a K220 or K210? I'm on K2
209.
209, yeah. That 209 will be like that.
Is it some, I have compiled in Desmos something. So is it something that we have to do in this kind of correction so that it goes to...
Yeah, so
This is the signal and this is just mx straight line. So I have modified the slope of the straight line and then I have brought it to 0.
so basically what is that value sine?
1 sin 5x plus 2 sin 6. This is one signal line.
Right, but this will not be like that, because when here you have only two frequencies,
Yes.
right? But in an earthquake there are a lot of frequencies, and those frequencies, how they are contributing, that you do not know. So basically what has happened, there is in your actual acceleration record, actual record, you have to first correct it. So basically that is your raw accelerogram. You have to make some adjustment with the raw accelerogram to make it a correct one, and thereby you need to remove from the raw accelerogram the very long period wave, because that long period wave is actually creating trouble in your displacement record, because the displacement data is a relatively long period compared to because you can see there is a trend is there, right? So that trend you have to remove it, because this trend is a long period trend. So if you can remove it from your acceleration record, then it will be corrected.
And it is only reflecting in the vertical component in this
Yeah,
case.
yeah. Mostly it will do the
Maybe
vertical
then on
component.
it's okay.
Mostly it will do the vertical component. Yeah.
For baseline correction,
Hmm.
we need some poly order or something.
Yeah.
So what poly order is made into?
The
So
poly.
it was calculating, I just used, but it was like running for the.
So how you got that poly order things?
I didn't get. Normally I was trying few values.
Yeah, no. It's basically you have to fit the
Polyfit, yeah. Polyfit I got.
yeah polyfit you have to calculate
Yes.
from the and you have to feed the acceleration record with your polyfit things, and something other fourth order polynomial or fifth order polynomial or sixth order
I
polynomial.
was using third order polynomial, but it was taking a lot of time.
No, that's okay. I am not interested to have a corrected baseline now. I am just interested whether you can calculate. I mean, whatever is the D is coming, that's fine. Just calculate this. We will be touching the baseline correction in the next class. So how to do the baseline correction, so that it will be all. And the baseline correction is not a unique number. So that means if you fix it for the one time series, and that will be done in the next time series. No, you have to again change it, because each time one you do not know how because what has happened is this, that whenever acceleration data is being recorded, this is the raw data. So from the raw data there is a trend, and there is a trend means it's basically the raw accelerogram has a instrumental drift and all these things, right? And so it will be always providing you a long period wave is inherent in the acceleration record. You do not know. So what you have to do, you have to first remove that the long period trend from the acceleration record. If you can remove that, then that long period trend will not interfere whenever you do the differentiate integration things. So then it will be come to the straight values. So that's the main thing. This can be done by two ways. One is the polynomial way, and other is the filtering way. So if you have to remove the low filter, low long period things, so if you can remove that, then it will be done. But this, how much will be the long period? It is for each station. So each station has a different phenomena. So you have to see the record, and then you have to try to see the adjustment accordingly.
So one more thing, few doubts. First is that baseline correction we are doing, so it has some long period, like the trending we get of seismograph. So in that case, why we remove that? There is a like low period.
No, because the low period
It's
thing.
like we are not interested in.
No, we are not interested in that. Because if your acceleration due to the drift it is going like this, you can first do one thing. You can remove the trend, so the trend will be removed, and then it will be coming back to the zero.
But I was
That will
thinking
be one way.
Yeah, it will be useful in like a deeper study, the long period. If long period wave will survive.
No. If your interest is the long period, then it is okay. Then that you can get. But this long period is associated with the instrumental drift. This is not associated with the ground
This is
ground thing.
like-
But it is only due to the instrument noise and instrument thing. So that's why it has to be done.
Alignment or centering.
Yes,
type of
yes,
things.
yes. So that you have to first
Another
remove.
question I have, sir, is suppose basically we have velocity meters.
Mhm.
Seismometer is like velocity meter.
Mhm.
So one way like from velocity we do we can find displacement.
Mhm.
And, from velocity we can find acceleration.
Mhm.
Other way around we have accelerometer where directly acceleration response the time series
Mhm.
we used to find.
Mhm.
So from that we used to get like velocity and acceleration. Which one is more reliable?
No, if you have a velocity meter,
Hmm.
if you have recorded a velocity meter, then always take the velocity meter reading as a corrected velocity. So that means that will be the authentic. But acceleration to velocity, whenever you are doing it, you are doing some integration or you are doing some filtering, because without that you cannot come here. So that will be always the derived parameter. If you do not have a velocity meter at the co-located position, so that means if it is acceleration, there is a velocity meter, then if you recorded both, then if you wish to know the velocity, then take the velocity meter from the velocity meter. That is definitely.
What displacement?
If you have a displacement sensor, but the displacement sensor is a very difficult to make. So basically, the people do not do the velocity sense. The people do the velocity sensors and calculate the displacement or the drift from that thing. But if you have a velocity meter, from that velocity meter you are doing the displacement calculation, it will be a little bit more authentic than from acceleration record if you are coming to the displacement.
Okay. Means acceleration response will be more authentic to find displacement.
No, the velocity is more authentic to come because there is only one integration, and here acceleration you are doing two integration, double integration. So basically you are making some mistake in the velocity first calculation. From the velocity calculation you are making another mistake in the displacement calculation. So if you have if you want to have a calculated actual displacement with a point accuracy, then do that.
Will the sampling interval will affect these things, because in accelerometer we used to have very high sampling rate.
Yeah, but, that will be your because whenever you are doing the velocity survey or the velocity sensing equipment, then if you give a very high sampling, it does not make anything, because the velocity acceleration it will be changing very fast, but the velocity is always changing slow. So unnecessarily putting the instrument to collect lot of data does not make any sense. So usually we do a less sampling in the velocity and much more less sampling if we have a displacement meter. Okay, so that's always the case.
No, I was just thinking let's say in one accelerometer I have just a sample at 200 sample per second and I am coming to displacement. Another is I have just a sample for like 100 sample per second and coming to displacement. There will be difference.
Then the noise will be little bit less in the 100 samples per second. That's definitely. But if you are using your accelerometer, you are using for a purpose,
Yes.
and for that purpose, then will be basically compromised, because you are compromising the purpose of putting an accelerometer than to calculate our purpose is not to calculate the velocity. Our purpose is to calculate the acceleration of the ground. Right. So that's the part.
Thank you.
So anybody go beyond the PGD and everything, or have calculated the area's intensity or something like that? No? Why not? So this thing is very difficult to calculate. So this is, again, the integration, and this is your acceleration square, and then divide by 1 by TD. Right? So TD means the total time. Okay? And then this is your total intensity is just only this part, right? You do not make a square root, just only make this, so that is equals to total intensity I0. And if you take out the square root from here, that will be the average intensity lambda 0. So if you calculate one, you are calculating all the others, right? So then, if you take the absolute values of this one and do the integration, then you can get a CAV, right? So this is all integration part. So just only different ways. So that means sometimes square, sometimes that square divided by TD, and then take the square root. So the main part is same. So then the area's intensity, if you need to calculate, this is pi by 2g, and then this is ug dot square. So that means that whatever the acceleration values, square it and integrate it over the things and divide by pi by 2g. G is the acceleration due to gravity, right? Does it make sense or no?
So, going to the old one again, sir. I have updated, you said, na, ki peak acceleration velocity and displacement to put.
No, this is not, this is in the accelerations, right?
Yes, sir. I have updated again.
Okay.
Sir, because you asked me to put this one, the
Okay.
values here. That one done. Sir, after that,
80 point something, right?
so this is for 209. I have other two.
Oh,
also.
okay.
Other two,
20 is how much?
two ones, 220. K220, which
359
acceleration.
and 21 and this one. Okay. But you are doing only the one component. But here you have a 3 component. So you have to write for all the components, right? Because this is the velocity for the
This is the peak velocity.
peak velocity for any component.
Any Z.
No. So you have to individually calculate peak values of n, peak values of e, peak values of g.
Individually, peak values of N,
E and Z.
Okay.
So how the things are? Hmm?
Velocity and some PGD. Velocity and PGD.
And the PGD.
Yes, sir.
Okay. So what else now? NP max. Okay. So all the three files has been done, or only the K220?
So only the K220.
So now you have to do the other files
Yes.
also, right?
Yes, yes.
Okay. So try it. So you can calculate the effective acceleration by No, just to go to the code. Just to go to the code. And so write down now, just write down the absolute, the square root. The square root, no, SQRT, square root, square root of your trapezoid. No, square root. Take the square root of trapezoidal calculation. So, no, not cumulative, just only trapezoid. So, no. You make the equal sign of, after that put a bracket, and then calculate the trapezoid, TRAPZ, trapezoid, and then you make it a T, comma, your, let's see, the north, what is your north component? North component is the acceleration, right? Yeah, north component square, north, NORTH, north comp, NORTH, north comp square.
Straightaway square.
The north component dot, put a dot, and then no, it's a dot to the power square. No, square root. No, dot, not this one, dot. And then dot with a power, dot. After dot with the power 2. So that make it a close, and divided by the divided by the total time. So the total time will be no. Yeah. You have to calculate this. This is your T1 minus T end. So that means T end minus T1. So that means the total time. What is the total time? So T or put a bracket. Then calculate capital T end, capital 2 with a capital, with a parenthesis, or the bracket end, END minus, bracket close, bracket close, minus T1. So that means from the, for the first value, T1, just your parenthesis, 1, and then put a bracket close. Yeah, so basically you are trying to calculate from the time value at the end of it, so suppose 120 minus your first value. Right? Total time. Right, and so now you can see that this is a square, so don't make it a little bit on this side, square to be the trapezoid. Yes, trapezoid T. So that will be equals to some, just give some name. So AE, or the effective acceleration, effective EA or something like that. let's see. So this square root will be the entire one. So is it this one? So this will be closed with. So check it out, whether everything is being correct or not.
2, 3, 4, 1, 2, 3, 4, 6.
Let us see if it calculates that or not. It shows there is a bracket problem. No, because there is one extra bracket is coming, so that you have to drop.
This is for this. So this bracket is complete, sir.
Then you put another bracket, let me see. You can put another bracket at the end. Is it taking? Yes, now it is okay. No, bracket, no. You can define this parameter in a previous line and then give a one value on there. So Tn minus T1, you define this as a total T or something like that, and then put this number. So now you can delete the bracket. Tn minus T1. And now put it here, the T, and I put it here, time T-I-M-E, and then bracket.
Total time is 120 seconds. T calculated. T is 120.
Yeah, time is T120, right?
Sir, did you mention about this one, like what I understood was, like previously I was getting one separate collective. Now I'm getting for all the three.
Yeah, 3. That will be fine.
I think this is what you mentioned, right? Sorry.
It's not? They're not taking it? No, it has to be divide whole to be time, because the time should be inside the square root. Because as per the definition, if you can go to the definition wise, this will be the square root things. Yeah, so I think this bracket is correct now, because there is a 1 and 2 and there is a 1 and 2, right? What is the error they are giving? No, you need to find out the
Terminal statement with semicolon to suppress output.
terminate statement with semicolon to suppress output within script. No, that's okay. That is, but you can take out this one. You can take out this one. Yeah, just to now do this.
I will check, sir. Why this is coming.
Yeah, so basically this is your time versus your this numbers, right? So so how much the progress? So then next, the effective acceleration and all these things. You have to do all the parameters, whatever we have done. Okay, so that everything we have to set it up. It's not that only the PGA and PGD. Area's intensity is coming out how much? 1.5
5 for north.
meter per second.
Yes, sir.
When you, meter per second is, yeah, I have to check. I do not remember. This is for which station? K220. Okay. So how much you are getting?
7.5 for north component.
For the north component, and for the east
So
1.5 meter per second.
yes, sir.
Okay, and
So 2.8 for vertical.
yeah, that's fine. So this is what I am also getting 1. I am getting 152, 151, and 280. So that's the same numbers, right? Okay, I like to show you another things. Please check it out. I will be showing it before it. Let me see. You can see it, right? Okay, so this is the response spectra calculation. Okay, so this is the response spectra calculation. I told you last time that this displacement response spectra we need to calculate, and that will be equal to the SD or the spectral displacement, and that depends upon the damping and the Tn values, right? And I had shown you that it will be equals to 1 by omega d into 0 to t. This is the acceleration record. This is the E into h omega n t tau, and this is your sine omega d, these things. And we have to have a maximum value of it, right? So that's your maximum value. Now, the thing is this, that we have to have a suppose the K220 time history data, we take the, let me see if I can make it a little bit bigger. Is the font size. Okay, I'm not sure. Okay, I am not sure where I can get the bigger one. But anyway, so I load the data with this value, which is your time history data, and I calculate from here u double dot. So u double dot means it's the accelerations, right? So acceleration value, I just give a name u double dot, right? So this is your acceleration. So this is the second column, and this is your time value, which is the data. This is your first column, right? So this is your acceleration value, and this is your time value, and I calculate the dt, which is basically the difference between two consecutive time values, right? And I also need the period value for which we will be computing these Tn numbers, right? So this Tn number comes from this period value that we have to provide. Right, so that is the period value dot dat. So the first column of this period value or the period data, the first value of the period data is basically the period values. So this is your Tn values. So all the period values are here, and I have fixed my damping. This damping value is a 5% damping, so H equals to 0.05, right? Okay, so and you can see this omega n. This omega n is basically 2 pi by the Tn or the period values. So 2 pi by period value is the omega n, right? And then what I do, I first calculate all the displacement value, all the u value. First I make it a initialization, so make it everything, because I keep a house where everything is empty, so that's your initialization. So that initially I make it every u from 1 to the entire length, of the time series is making it as a 0, right? So this is your 0.0, so I make all the values 0. And then I calculate also omega d. Omega d is this number, right? So this is equals to your omega d, and omega d means it's a omega n into square root of 1 minus damping square. So the 1 minus damping square is basically the omega d value. So omega d equals to omega n into square root of 1 minus damping square. So that is this omega n means is a 2 pi by Tn into this one. Ug double dot is the observed acceleration, h is the damping factor, omega d is the damping frequency, and omega n is the natural frequency, right? So that's all the numbers you need. So so what you calculate, you have to calculate this thing. So this Ug dot and this function, that means after exponential, they are convolving each other, right? So this will be convolving each other. So that means h omega n t minus tau and this t minus tau, these are the convolution part, and tau is the only this one. So what I do, I calculate first this parameter e to the power h omega n t minus tau. This I say it is a capital A, right? So this is a capital A. So the capital A will be the exponential of minus, say suppose this is your minus value, I put it here, and then h omega n and dt, right? So h omega n and dt is the time, or d tau is the time I need to calculate, but it has to be from 0 to entire length of this data. So I have a n number of data. So that n number of data means 0 to length u double dot minus 1. So that means because since I have started from the 0, so the entire length will be n minus 1. So it's a 0 to n minus 1, and then h omega n into this is your dt. So this value of dt, so that is your a, and b will be equals to the sine omega d. So this is your sine omega d into dt, because this part is basically dt, and this t minus tau is basically 0 minus length double dot and minus 1, right? So that's the same thing as we have done it here. So this is all your t minus tau factor, right, into dt. So a into b, I multiply a into b. So a into b into dt is this one. So that is your g, I defined it, a dot multiplication b into dt, and that's fine. And then it has to be convolved. If I define it as a g, so then u double dot thing, so that means this is your ground acceleration, comma g, and that is a convolution. So this is a convolution of u double dot, that means this function, comma this entire, this two term, which is basically the g, and then that you first calculate u, and that u has to be divided by wd, so that will be equals to your u1, and that u1 maximum value, because I have to calculate maximum value of this u1, so maximum absolute of u1 will be equals to your spectral displacement. So you have calculated the spectral displacement for all the values, so that will be fine, and then you can take the spectral displacement values and calculate the spectral velocity response SV. So SV will be defined by this way. So just you differentiate this one. So if you take the differentiation of this displacement, then you can get SD in place of SV, and then this will be equals to, just by differentiating of this part, I think I should make it a UG. I think that this is your UG. This is not XG, this is the UG part. So this is the cos omega t into this function. So this is another one. So you have just defined the again, this will be the convolution of, it is a convolution of u double dot, so this part into L. L means AC into dt, so A is the same function as your previous one, because this is the exponential function, A part, and then C part is basically, I am defining, it is a cos omega d minus t, and into this part, right? So that is your, this one. So u dot t and then dot u, you just calculate it, so that will be your SV functions, right? So, so that SV, and then if you take a double dot, then that will be the SA, and that will be this function, and it will be like this way. So then you can calculate the spectral acceleration will be this one, and then the spectral velocity by this one, and then you can calculate pseudospectral things just by multiplying this one with the SD, and pseudospectral acceleration with the omega n square into SD. And that all the things you can plot. So I plot the time history, then plot the spectral displacement, plot the spectral velocity, plot the spectral acceleration. So these are the spectral acceleration values. And then I do the PSV, pseudospectral velocity, which will be like this, and then pseudospectral acceleration, which will be like this one. So this is your PSV and the PSN values, right? So that is your, this SD with the omega n, SD with the omega n square, and that we have already discussed in your text in that yesterday, whatever I have done. So then all the function has to be the plotted one. So does it make sense to everybody how to calculate this one? This is your spectral response calculation of your recorded data. And I had already told you last time that these three things, that means the spectral displacement, that is the spectral displacement, and the spectral, pseudospectral acceleration and pseudospectral velocity, we can put it on a tripartite plot, and then we can calculate whatever that will be the spectral acceleration, all these things. So I will be sending you this code, and you can put your all other things, and please understand this code. This is your Duhamel integral, and this Duhamel integral you can see in your text or the PowerPoint file or the number 4. Everything has been explained, so you can use that to calculate these different things, right? I have to see whether my C equals to cos 2 minus. Okay, so okay, so you have to do this one for all the 3 sites and see how does it looks like. Okay, I will be try to see it in the next class that you had some data generated from here, right? So next time onwards, if you use this code, you just make it a subroutine. you just give the time data and also the acceleration data, and then it will automatically calculate for any time data and acceleration data you want to give it to them, so that it will be plot and also the compute the values. Okay, so try to see these things on tonight. I will be sending you.
Sir, one small thing, just a clarification. So far we have done PGA, PGD, and
And you have to calculate the effective acceleration, the absolute acceleration, and all the values as it is being written on your PowerPoint file number 3. So lecture number 3, there are all sorts of parameters are been given, and I had shown you today what are the parameter listing you have to do. So you have to find out all those parameter values. Okay, so the PGB, PGA, PGD is in addition to that. So you have to extract all the ground motion parameters. Okay?
following the lecture.
Hmm?
Following the lecture.
Yeah, following the lecture 3 or the PowerPoint 3. Okay?
So this code is available in Google Drive.
Huh?
This code is available in Google Drive.
Yeah, I will be putting it into the Google Drive. Okay, along with the period values, I'll put it into the. But this is in a MATLAB. But if you like to write in a Python, or might be the ChatGPT will help you to write it in Python, then you can try that. Or ask the ChatGPT that this is the data. Give me the PSB, SB, SA, PSA, all the numbers, so that they will show you. I have no clue.
Sir, it cannot help you if you don't tell us. That is
No. I am not telling you, but this is the calculations. So calculation you need to learn, because otherwise you cannot do it in future. So the ChatGPT will be given you, but the ChatGPT will not be given you at the time when you need it most. Okay.
without you we cannot do anything.
No, that's not the same. There are a lot of people can learn without me, but you have to do it of your own. Done? Okay.